Right. Good evening, everybody. Welcome to Brian May, which is our special jam this evening, celebrating all things rock music, astrophysics, rock guitar, curly hair, all those kind of things. So if you've been with us the last year or so, you'll have seen that every month we have a different theme. Last month it was April and it was all about how does your garden grow. We had March of the Robots. This is May, Brian May, and you may know that Brian May, it was the legendary guitarist and is the band Queen, but he also is, if you go and find, he has a Twitter profile, and he is a rocket scientist as well, an astrophysicist, and all of those kind of things together. So we have a lineup of talks planned for this evening. And then a little bit like you might guess as a gig, we've got an after show party afterwards. So we normally call this the Jam Jar, where we set up some breakout rooms and some of you will come and join us in there. And we'll have lots of informal discussions going on in there. Now, we're going to move. Is there anything else I need to say? Well, if you're on Twitter, if you're on YouTube, you're doing really well. You're chatting as people are. We've got lots of different people on there at the moment. We've got about 20 odd people all chatting on YouTube. So thank you for doing that. If you see anything, you have certain questions, and we'll try and pick those up as we go along. Now, we're going to move on with the program. So joining us this evening, we're going to link over to California. Now, I don't know if you've ever looked to see, what goes on in California and time zones and things like that, but we are 8 hours ahead of them. So they're actually at the start of their school day in California, well, more or less. So they've recorded a video, especially for us to show during our event this evening. And I just need to go and find that video now. And it lasts about 10 minutes or so. The teacher, Sean Razor, who's the computing teacher at California High School, he's going to introduce us to the school, and he's going to tell us a little bit about the projects the students have been working on. So let's just hope I can do this nice and smoothly. I practiced it earlier today, but we know that that doesn't necessarily always mean that it's going to work as planned. One moment. And hopefully this video will play nice and smoothly. Now I need to go and click on the play button. Now, if anybody has any audio issues or whatever, let me know.
My name is Sean Racer, and I'm a computer science teacher at California High School in San Ramon, California. San Ramon's actually it's close to San Francisco. It's about 30 miles east of San Francisco, so still considered Bay Area, but just kind of East Bay Area. Um, I also teach Raspberry Pi classes after school, and I've led a number of jams in the community and for my school district. And I actually met Alan after I attended a few of his jams this past year. After everything shut down and went remote, I had some flexibility and was able to attend some of those and really enjoyed them. One challenge I've had this year is incorporating Raspberry Pi into my curriculum. I have a class set and I have a lot of stuff in my classroom that normally the students can use while we're there in person. But since everything's been remote this year, I haven't been able to use those. So once we were able to start bringing some students back on campus, I was able to start an after school club. I called it the Maker Group. And it's a group of students who have been coming in twice a week, and they've been exploring making and programming with the Raspberry Pi. Some of them have been using the projects off the projects page or other various resources that we found online, but it's been a lot of fun. It's been great seeing the students in person, and I've just been very impressed with just how well they've done and their engagement and their interest in this. So this video is some of the students from my maker group sharing some of the projects that they've been working on these past few months. I hope you enjoy, and it's great to be part of this jam. All right.
Hi, my name is Mukesh, and I'm currently working on the Pi car. Basically a robotic car that's powered by the Raspberry Pi. I'm currently still working on it. I think I'm about 60% done so far. Yeah, I want to see how it turns up. I think it's a cool project.
Very cool. What other stuff have you worked on in the Maker group?
So I started on this a few weeks ago, and when I initially came to the group, I did projects on the Raspberry Pi top seed. I did a couple of games, and then I used the SenseHat, and then did some displays on that.
Awesome. Thank you very much.
Thank you.
Go ahead.
Hello, my name's Hal. I'm also participating in Mr. Razor's Raspberry Jams, and I've made a Connect 4 game. So, as you can see, pieces will drop based on the number you type. And, 2, okay. And 1, 6, and then, and red has 1.
Very cool. So it detects it diagonally, vertically, and horizontally?
Vertically, diagonally, horizontally, and it can even detect a tie in case the board gets filled up by some miracle.
Nice. Was this hard to do?
It was okay. It wasn't, I mean, getting the board and like finding all the positions was hard, but yeah, I guess given enough time you can pretty much do this.
What do you think you're going to work on next?
Next, honestly, I have no idea. I'll probably, maybe Hangman would be nice, and try to illustrate that on the Sense Pi.
Awesome. Thank you very much. Thank you for sharing.
Oh, hi. I'm Sonica, and I'm not working on anything particularly like major. It's just an ultrasonic detector system thing. When you go out of range, it'll just print by. It's not very complicated, but I hope that eventually I'll work on this other project that's gonna like play sound and music.
Oh, the theremin?
Yeah, the theremin using this setup. Yeah.
Right. And what else? I know you were working with the SenseHat previously. What kind of games did you make with the SenseHat?
Oh, we made Flappy Bird, Pong. What else was there? Oh, Slug. Like, yeah.
Nice. Do you enjoy it? Have you enjoyed working with it? And
yeah.
what kind of things have you learned from it?
I've learned like a lot about programming and setting up and debugging my stuff, I guess. Yeah, that's a useful skill.
Awesome. Thank you very much for sharing. Go ahead.
Hi, my name is Yuvraj, and I'm part of Mr. Razor's Makers Group team, and I have created a rock, paper, scissors program using the SenseHat along with the Raspberry Pi. So if I run it, it will ask you for an input for either R for rock, P for paper, or S for scissors. And if I click R, it's going to tell me if I won or not, and it's going to display the computer's choice on the SenseHat. So I click enter. So as you can see, the computer chose scissors, so the rock beat the scissors, and I won this round. Now let's try S, or scissors, as my choice. So the computer chose R, so I lost this round because rock beat scissors. And let's choose P for paper. So I lost again because the computer chose scissors, and scissors cut the paper. And let's choose R again. So the computer chose scissors, which means I won because rock beat scissors. Let's try P this time. And as you can see, that was a tie, so I chose paper and the computer also chose paper. And let's try rock. And I won this round. And since I won 3 rounds, I get a message telling me that I have won, and it states, "Great job, you have won the match." Awesome. So that's my project, and I love working under Mr. Razor.
What do you think you're going to work on next? What else would you like to make?
I am planning on working on the Pi camera along with the circuits.
And you also worked with the Solve for Tomorrow group, right?
Yes.
And you guys were prototyping. What were you prototyping earlier in the year with
we
Raspberry
were
Pi?
prototyping a depression bot that could be useful in curing depression. Unfortunately, our project wasn't selected from Samsung, but next year we're going to try maybe another project.
Are you guys going to still try to work on the depression bot, or?
We haven't planned anything for that, but if we plan the depression bot, and we're going to make sure it works better and it's a more overall, a better system.
Awesome. Thank you very much.
Of course, thank you.
Hey, how's it going? Armin here. So I've been working with the Raspberry Pi for a while now. I started on the SenseHat, did a marble maze game, which was super cool. Taught me how to use the orientation of the Raspberry Pi, or the SenseHat rather. And now what I'm working on is an RFID attendance system. So this has taught me a lot actually about wiring the LCD, the RFID. The whole thing has been such a new experience. And so I'm gonna demo it for you guys real quick. So right here, we're gonna try to save a user. So you see it says place card to register. We're gonna do that, enter new name. I'm gonna go ahead and enter something different actually. Let's do Nick. So we have that, and then we could exit out of that and do our check attendance. So we could use the same card. If we tap it, it's gonna say welcome Nick. And also, I learned how to use MySQL and how to keep track of all these logins and stuff. So I could do that. Hopefully that doesn't take too long. Let's see, it would be command is somewhere up here. There it is. So from here we could do from, actually, select. We could show our users. Let's see.
Good little troubleshooting.
Yep. So as you can see, we have our users, this new one that we just created, Nick, and some of our past ones. And we can also pull up our attendance record. Right here, as you can see, we have all these ones, and this is the one that we just did right now with Nick.
Very cool. And what are the next steps that you're taking with this? What are you working on next?
So what I'm doing next is actually making a web front end for this, so that it's gonna look all nice and user friendly. Yeah.
Awesome. Well, very cool. Thank you for sharing.
All right. Thank you. Of course.
Okay, so I can stop the share there. So I will say thank you so much to the students and Sean from California High School. So they're not all necessarily students who attend the school there. Some of them they attend the community group. So and if you're watching this now and you're thinking, oh, maybe you could be a student, you may be thinking of persuading your teacher would be a good idea, or you could be a teacher, and I'm looking at some of you now. You could maybe persuade some of your students to join, or maybe you're neither. Maybe you're somebody who knows a student or a teacher. You could say, I've been talking to a teacher today who teaches in London, and he's got some young children that are 8, 9, and 10 years old, and they've done some amazing projects. They asked me to act as a judge of them, and I said, you really, really need to please come along and show off what you've done at our jam. Now, we've changed the order around just a little bit. We've swapped 2 of the presentations. So we were going to have Caitlin up next, but instead we're going to have Geraldine now. And then we're going to go to Dave that we had scheduled. And yes, and then we're going to go to Caitlin. So we swapped Caitlin and Geraldine around. So I hope that Geraldine now is there, switching on her camera. And
hello, Alan.
Great. And what we'll do is we'll share. You had some slides that you've given to me, and I've got the slides in 2 different versions. So I'll share those now for you.
Okay.
Give me one moment. I'll just get them on the screen. So we have. How does that look? Something like that?
That's the slides. Thank you.
And I can zoom in so we can see one slide at once. And if you want, you can say next slide, please. And then I'll go all Brian May and I'll strum and whatever. So take it away, Geraldine.
Okay, so as you've got there, I want to break free, which is a great thing to do with Lego, to use our imagination and be creative. And with it being the month of May, it's also my birthday in May, so it made me think about cake. So I have got Lego and cake together. So if you go to the next slide.
Next slide.
Yeah. So I'm experimenting with the Raspberry Pi. It's all new to me, and I want to introduce Raspberry Pis to school. And Alan, you did a great Raspberry Pi session for us in school many years ago, if you remember. So that's something I want to do in school. So I'm teaching myself first, and I did a little course with the Raspberry Pi Foundation with the physical elements. And I thought, why don't I put the Lego, the cake, and the Raspberry Pi together and a little bit of music and see what I can do. So I came up with the idea of a cake, which I've got here, with some birthday candles, so LEDs, and I'm using a buzzer to play the music. For happy birthday. So if I take you through the story of the project, and then you can see the final results. So next slide, please.
Nice.
So as you can see with the Lego, I have built what looks hopefully like a cake. I do realize I'm very much a programmer and not an architect, but there we have our cake. And if you go on to the next slide, please. That's the breadboard where I have put 3 LEDs, and I'm not sure if you can see it. I can't see it on the screen, but there is a buzzer as well on that breadboard, which plays the music. So the next slide, please.
Oh, let's go to the other tab.
Oh, okay. So if you go to the next slide, please. Oops.
Right. Is it?
Yeah.
You can see everything okay?
I can see everything perfectly, thank you. So I got my breadboard ready and the Lego, and then I thought I'm going to have to write the program. So I've broken the program down here. I've decomposed the problem. So it starts by switching on the candles, then asking the person their name, playing happy birthday to them, having a little pause, and then the blowing out of the candles, so the switching off the lights. So if you go to the next slide, please. And you need to click again to see the image.
Oh.
Oops. Oh, yeah.
Did you want it to play a video? No?
No, thanks.
Okay, let's go back.
Okay.
But I've never really...
Okay.
Okay, so you can see there, that's the video I had looked at. I looked at that video to come up with some ideas of how to play music on a Raspberry Pi. And I've got the Raspberry Pi 400. It doesn't have sound, and neither did my monitor. And in the end, I just thought, you know what, I'll use the buzzer because I've learned how to use that. So I didn't use that video immediately, but it became helpful later on. So if you move on to the next slide, please. And the next thing I had to do was find the notes for happy birthday. So I did that online. And if you go to the next slide, please. And there's no need to look at this now. However, I found, Alan, it's quite a problem looking for documentation for the Raspberry Pi. I was using Tonal Buzzer, a library for the music with a buzzer, and there's not much out there. So I really was, doing a lot of searching. If you go to the next slide, please. And you don't need to click on this either, but my code is there if anybody wants to see it. I've stuck it on paste bin. So I finally wrote the code. And next slide, please. So when I tested it, my problem was it didn't sound anything like happy birthday. And I realized I took middle C as my starting point, and I just kept adding 1 for each note. So, 66. So middle C was 60, and then I did 61 for D and so on. But I wasn't thinking about the flats and the sharps and so on. So I went back to that Sonic Pi video, and this was all nicely outlined there. So that really helped me solve the problem. Okay, and finally, I think we're on the last slide. And my evaluation, what do I think about this? I had great fun. I think the students at school would love doing things like this. I think it would be better if I had LEDs that had longer legs so I could make it look like a proper cake. And your technical team have told me, in order for me to demonstrate this to you, the microphone is not picking up the sound of the buzzer unless it hears me singing with it. They've seriously told me that. So I'm going to demo it to you now, but that's why I'm singing along.
So shall I stop the slide share now?
You can stop the slides, yeah.
Okay.
Have you got any questions so far?
No.
No? Okay. And can you see the cake there? And the LEDs are not on yet, but there's some, you can see that there? Yeah, okay. So I'm going to click run. And it's going to seem strange because I'm going to sing and I really don't want to. So we go with it. Okay, it's asking me my name. Birthday to me. Happy birthday to me. Happy birthday, dear
Geraldine. Happy birthday to you.
Okay, and the next thing, I think, can you see the lights on?
We can, yeah.
So I'm going to blow the lights on. So it's asking me when I'm ready.
Oh, we're just losing Geraldine a bit. We can hear you.
You can hear me?
We can. We lost you a moment ago.
Oh, you lost me. Okay. Hopefully the bit where I was singing, you lost me.
Okay.
Have you got any questions?
So we've got a few comments in the chat. We've got people chuckling. We've got people wishing you a happy birthday. So is today your birthday? Is that?
It might be.
Okay, maybe.
Yeah, maybe my birthday today.
And somebody was going to ask a question about the connection between Brian May and Lego, but I don't know if you'd want to answer that, or
do you want me to answer that truthfully, Alan?
Go on.
There's quite a story behind that, because when you said Brian May to me first, I don't know why James May came into my head, and I was thinking James May Lego House. So I did the wrong homework. However, you managed to nicely make the connection with Brian May for me there. But I was also thinking month of May being your, I'm sure that's the reason why you went for May. Yeah, month of May. And I thought, well, my birthday in May, let's do a birthday cake.
It may be. So, oh, I can hear across the country people are singing happy birthday to Geraldine. Okay.
Thank you.
So, Geraldine, you work in a school?
Yes.
Have you ever thought about suggesting some of your students maybe present as one of our jams in the future?
I think it will be great, but Alan, as I said, I've just been looking at this because I want to get a class set of Raspberry Pis. So I did some training myself first and played around with a project like this. I've talked to our sixth formers and our GCSE students, and they all want me to get Raspberry Pis into the school. So once we do that, I'm sure they'd be really happy to do that.
Well, you don't have to have a Raspberry Pi to come on here. We have people, like last month, we had somebody presenting using Arduino. The month before, we had somebody just using cardboard and paper. So I think people have this idea that you can only present using a Raspberry Pi at our events. And in fact, the projects that I was looking at earlier today that we hope to bring next month, some of them are using Scratch Junior, Python, and there wasn't a single Raspberry Pi to be seen.
I'm sure I'll have students who'd be delighted to take part.
Fantastic.
I certainly enjoyed watching the students just prior to me. That was fascinating.
Geraldine, thank you very much for joining us, and I hope you can stay around for our live chat and maybe join our after party.
Okay, Alan, thank you very much.
Thanks, Geraldine. Bye-bye. Okay, so our next presenter, we're going pretty much on schedule now, except I mentioned we did a swap with Caitlin and Geraldine. So we have Dave, who is at Dave Javu Pride on Twitter, and Dave is going to be turning his camera on in just a moment, and he's going to be presenting. Did you remember, did you see on the program for tonight's event what Dave had put down? So it's some, I don't know where the word Dave came. Oh yeah, Dave, yeah. So it's rain must fall, how to receive images from weather satellites using one of those Raspberry Pi computers. So Dave, are you there? We can hear you. We just, oh, now we can see you. Good evening.
Occasion. How are we doing?
Fantastic. Okay. And one thing I'm going to do now, I'm going to find out how to do is pin your video to the main thing. Right. Over to you, Dave.
Well, greetings. Good evening, everybody. Well, I'm just going to start. I'm just going to share my screen and make sure we can all see where we're going from.
While Dave is doing that, anybody who comes back later on to watch, you can just click on the timestamps and we'll get to this bit. All right, that looks good.
Okay, are we good to go?
Please, yeah.
Well, good evening, everybody. Thanks for giving me the time to talk to all of you. My name's David Pride. I'm a researcher at the Open University during the day, and I've been a Pi aficionado, shall we say, for a few years. And this particular one is about receiving images from satellites with something called RTL-SDR, which sounds awfully technical, but I promise you it's not. It's really actually quite fun, quite straightforward, and really easy to get started with. So this actually came around with these little dongles, and you may well have seen, I'm sure some of you, if not many of you, have seen these things, which were originally used for receiving digital TV through a USB stick on your laptop. So you could take your laptop camping or on holiday and receive a TV signal. Unfortunately, they were universally rubbish, really, until a chap called Steve Markgraf and a bunch of developers at Osmocom realized that these were actually a pretty wideband radio receiver that could be used to receive any radio signals, not just digital TV, which is just another form of radio signal. And this brought in the definition of budget software defined radio. And to that end, the market then went kind of a bit crazy because there was clearly a lot of appetite for this, and a number of these dongles are now available. And they literally start at about $10, and they can pick up AM, FM. This wonderful stuff that I got into first off with this, which is called ADSB, which is automatic dependent surveillance broadcast, and all of this sounds remarkably and sketchy, but I promise you it's not. And a question I often get asked about this is this legal? And it is. It's absolutely legal, all of this. And what you can do with these dongles, if you get a dongle and then build yourself an aerial, and this particular aerial I made is called a dipole antenna. You see there, it's literally made from chopped up pieces of coax. And there was a wonderful program called Dump 1090, and 1090 is actually the frequency of the ADSB broadcasts, which are the pings that aircraft transponders put out as their location beacon. And if you capture these pings, you can capture the location of the aircraft. And then using Google Maps was the way it was originally done. You could have map the positions and do lots of clever things. Now, these days, there's something called FlightAware, which many people will have seen. And there's another one, which is super cool. It's called PiAware, which is literally an SD card image. You just plug it into your Pi, plug an antenna on the other end of one of these £5 dongles, and you can map aircraft. Now, this one was taken quite recently. And one of the things you'll notice here is the lack of aircraft. So you can see it was quite clearly taken down through lockdown. But the antenna I used for this will pick up aircraft in a range of about 300 miles. So that's right down over France, right up into the Lake District as well. It makes you realize we're a lot closer to France, or I'm a lot closer to France in Milton Keynes than I am to places in Scotland. And I did this for a while. It was really quite fun, but then I realized there's an awful lot more things in the sky of interest, and in particular, and this has been done by a lot of people, is there's a series of satellites called NOAA, and please don't ask me what it stands for. It's a national or something organization. Go Google it. And they've been launching satellites since 1998, a series of these, and there's three of them still in orbit, which is NOAA's 15, 18, and 19 are still going, and they're still spitting out data, and it's actually an unencrypted data stream. Okay, and it broadcasts on something what's called APT, which is automatic picture transmission. And I got super excited when I heard this. And essentially, there's no storage on board of these things. They literally pick up a picture and they transmit whatever they're overhead. And these are geosynchronous orbits, sorry, polar orbits. So they go around the Earth and they orbit the Earth about every 90 minutes. And you can pick them up as they go ahead. With the right antenna and the right software attached to the dongle. So I got really excited about this when I first heard about this, and I went and looked online and I found something called a cross dipole antenna. You can see quite clearly why it's called that. And I went out and I got a load of aluminium rod and I very carefully followed the instructions online as to what I was doing. And I got super excited as we were going on, and I was using something called GQRX, which is available on the Pi 4. Don't try this on anything less than a Pi 4. It just can't hack it, basically, and actually getting GQRX to run on a Pi is not quite as straightforward because it uses pulse audio, which is a bit of a bugger now, pardon my French for any juniors. And I got tuned it in straight away to one of the satellite frequencies, and when there was a pass due overhead, I picked up this really, really nice strong signal. And I must confess, I jumped on Twitter and I was like, fantastic, I picked up my first signal, and I sent out a tweet that said, space beeps, who knew it sounded like an 8-bit video game? And hopefully you can hear that. It was a really loud, really strong signal, and I was super excited until somebody pointed out to me that that was actually a pager, and I wasn't detecting signals from space at all. I was detecting signals from about 300 meters down the road from a pager tower down here that was pretty much swamping everything that I was trying to do, and this antenna really just wasn't cutting it at all, basically. So I managed to move the antenna outside and moved it higher up. And when you capture a real signal, you have to use a piece of software that's open source called Audacity to downsample it, which is just changing the bit rate. So the next piece of software, which is called WX2Image, can actually then automatically convert the data stream that you've saved into an image. That's all done automatically for you. There's nothing difficult about that. That's literally a point and click process. And when you actually do get an actual NOAA signal, you'll actually find out it really does sound like an 8-bit video game. So that's an actual NOAA signal being transmitted from about 900 kilometers up in space when it's right overhead, and about 3,000 kilometers when it's away. So I picked up a signal. You could quite clearly hear there was an awful lot of static in them. That's giving away what I've been watching on YouTube. But I actually managed to, with the right software and the antenna, we got an image, but the results were pretty poor. It has to be said. Now, don't get me wrong, I was completely thrilled to see this image here. Very, very happy, but I knew I could still do a lot more. So we went back to more research and yet more antennas, and this one is actually called a quadrifilar helicoid. And I'll give you some links. If anyone's got any questions, do just put them in the chat and I'll try and pick them up afterwards. With this antenna, this gives you a much clearer signal, and I can talk to people afterwards about why, if people are really interested. And with that antenna, we actually started to get some images that are much more like it. Now you can see these here are from NOAA 15 and 18. The overlay is actually based on telemetry data that was received from the satellite. And the overlay, the color image is actually done, is false color done using the IR signal. And I'll speed up because I've only got a minute or so left. Some of the things that you have to deal with when you're trying to do this is dealing with other radio signals, dealing with interference from anything electrical in your house at all, really. So I built this kind of box because, well, laser cutter, to put everything in. You can see I've got 2 filters on there now from a company called Newelec. One is a specific one to boost the signal in the specific bandwidth that the satellites broadcast in, and the other one is to squash all of the other signals from all of the other local stations to try and squish those down as much as possible. And you'll also see it's in a nice aluminium lined box to kick out any RF signals from local stuff. And with all of that in place, you actually now start to get some decent images. I was absolutely thrilled with this one. The X is actually quite clearly where what the ground station is, i.e. that's me. So you can see that's Milton Keynes, just north of London. And you can see just this was taken on the weekend, and you can see just on the right, the huge lump of weather that's just hit us over the last couple of days. So all in all, I've learned loads. There's loads more to learn. You will find some fantastic images out there on Google. Do some searching. You can spend literally hundreds of pounds on the kit for this, or you can use a cheap dongle, some chopped up coax, and you can get some fairly reasonable results. This is one of my favorites, and you can see again, if you look down over the Alps, you can see the level of detail down over the Alps is fantastic. So thank you for listening to me this evening, and for listening to me share this. If anybody wants any questions, please do post them, or I'm around afterwards. And with that, I'll hand you back to Alan. Thank you.
Dave, that is fantastic. One question I would like to ask is, approximately, those images are amazing. Approximately how long does it take for one of them to download?
Pass is about 11 to 12 minutes. It depends on how high above the horizon it goes. So it's actually slightly shorter as it goes over a high pass, and you get longer as it goes over shallower pass. And it's constantly streaming that data. And you can see on the right-hand side of this picture here is you've got the image lines, and that's what it uses to actually error correct the image as it goes. So that's one image that's picked up in an entire pass, and you'll record about 7 or 8 minutes of really nice clear audio, which will result in a picture like this.
That is fantastic. And Paul, will you be joining our after show party, the jam jar later on? I've just called you Paul. David. Yeah.
Yes, I will be here.
The reason I ask is because Paul had some questions, and Paul often joins us. So it's a breakout room. So everybody's invited after 8:30, and it means that almost as if you're at an event, people can then go and chat and talk to each other. That is an absolutely fascinating project. Thank you so much, Dave. And we're going to be going to Caitlin next. So I need to see if Caitlin, can you hear me there, Caitlin?
Yeah, I can hear you.
Great. Okay. And do you need to share anything?
Yep.
And you're joining us from the South End area, Essex. Yeah.
Yeah.
And Caitlin is a member of a group that we're very grateful. They come every month to present the Essex STEAMettes. Caitlin, over to you.
So I'm going to be talking about the MiniMu musical glove, made by the Open UK Kids Camp. So this is a fully made version of the glove. So on the left, so you can see all the components of it. And then on the right, you can, like in the middle, you can see the components to make it. So you've got the fabric with the template on it. You've got the buzzer, I think, the Microbit, the speaker, the 3 crocodile clips, the wire, and the battery pack. And then on the right, you can see our meetings that we do for the Essex STEAMettes. So we also were recording live video diaries of them. So people had their own videos of what they did with them. And so yeah. So that's the website, and now I am going to share this small video that's just a demonstration of what the glove does. Let me just make sure. There we go, share sound.
Brilliant.
So that's what one of the Essex STEAMettes have done. And I've actually got one on my glove at the moment. Let me just, if I turn it on. And as I move my hand around, it just makes noises. It's a bit glitchy because the crocodile clips aren't in properly. But yeah, that's basically what it is.
And can I ask Caitlin, about how long do you think before you got it, you got all the components together and then you started building it? How long before you got it to actually make some noise?
It took about, like for the first project, it was about 5 minutes to just get it to make a little noise and things like that.
That's great. And just could you just mention again the Essex STEAMettes? Do you know, how did you find out about that? Did somebody recommend you go, or?
I honestly don't know. I think I just was signed up for it one day and ended up going since then.
So for people who don't know, Southend is a town on the southeast coast. If you were to head north out of London in northeasterly direction, eventually, well, you probably go on the train, you get to this area of Essex where they have a raspberry jam in Southend. Have you ever been to the raspberry jam, Caitlin?
I went to the Basildon raspberry jam.
Okay. And then Essex STEAMettes is a group, and they've been meeting up online for the last 12 months or so. And there's lots of different people like Caitlin who've all got different projects that they've been working on. Caitlin, thank you so much for joining us. And we hope that you'll be able to join us at some other events in the future. Thank you very much. And we next have, in fact, it's worth telling you, I suppose, that we have 8 sessions in our timetable tonight, and we've just finished the 4th one. So that means we've got 4 to go. So just as a reminder, we've got Scott coming up next with One Vision. Then we've got Dr. Footleg with It's a Kind of LED Magic. Then we have Mike, Flick of the Wrist. And then finally, we have Garry, possibly with his robot. Scott, thank you for joining us. We missed you last month. We know you were here, but you didn't present last month, and you're muted at the moment.
Yeah, I was trying to get this thing going, and we're having a little bit of temperamental challenges at the moment, Alan, but let's see how we get on.
Well, we like to know sometimes that it's no good just turning up and saying, look, here's this fantastic finished project. It just worked from the moment. Like Caitlin said, hers only took 5 minutes or so to start getting things working. So it's nice to hear sometimes that people do sometimes struggle to get things to work. Okay.
Right, I will just share my screen.
So for people who don't know, Scott's never been to one of our physical jams in Preston, but since we went into lockdown back in April 2020, Scott's been to pretty much every, I see what you've done there. Machine learning.
Machine learning.
Okay. All right.
Okay, so this is a project I thought as soon as they mentioned they were going to do guitars this month, I was like, I know exactly what I'm going to do. So I'm going to present a couple of problems that you might have had back in the 80s as a guitar player, back in the height of guitar mania. And a couple of problems, and then a solution that can combine those two things using modern computing that you didn't have back in the 80s. So guitar heroes. Back in the 1980s, the real heroes on this earth were guitar players. And guitar players were the thing. But the 80s were a difficult time to be alive. No internet. So this is, this made it much harder to learn things. And if you were a guitarist, you had to learn things like scales and chords. There was no Google. You know, you had to do things like read a book, or, you know, maybe go and make friends with a real human being that you would then have to speak to, and they would teach you how to do things. So this elevated the people who could play, you know, to champions among mere mortals like they were dealing with. However, this came at a cost. Now, this is the cost: guitar face. Now, you know, look at all these poor people, struck down by having to learn how to play scales and chords, and they've had to contort their faces like this because it's so difficult. Now, you know, this is a serious condition, A major, not just a chord, this is a major condition. And then there was another problem that came in the 80s as well, and that was synthesizers. Now, synthesizers brought along with it another problem, which was the keyboard player. Now, here's some cons for the keyboard player. They think they deserve an equal share of band money. They've got weird big finger spans, got multiple instruments, and also a lot of them got to sit down. You know, that's not good when you're a guitar player. But they did have one major pro, which was that they would play chords while you soloed. Now here, down in the corner here, Mr. Eddie Van Halen, you know, possibly the greatest guitar player of the time, reduced to playing a keyboard. You know, it's one of the big things that I think is such a shame from that time, is that, you know, the greatest guitar player of his generation, his biggest hit was playing keyboards. So I got to thinking, well, how can we get around this? So back in the 80s, you know, this was your computer, this was your home computer, relatively expensive. Whoa. Sorry, technical difficulties. Yeah, so this was your whole computer, ZX Spectrum. It's a great little thing. A lot of us learned how to use this to work computers. But very little memory, no webcam. You know, you might be saying to it, oh baby, can you see? And no chance of doing artificial intelligence. But now we've got this thing, which is the Jetson Nano, which is what I'm going to be using, and hopefully it's going to work. Relatively cheap nowadays, £60 for this, for the 2 gig version. Lots more memory. You can get a webcam, which gives you vision. And this thing's built for artificial intelligence. So this has been especially designed to be a little challenger to the Raspberry Pi, but it's more designed with artificial intelligence in mind. So it's probably less easy to use than the Raspberry Pi, but it does have sort of bigger processing power, and it's more designed for doing artificial intelligence. So last month, Andrew did a chat about computer vision and machine learning, and he talked about convolutional neural networks. So in case anyone wasn't there, you know, this is the background to computer vision and to how a computer sees. It produces lots of matrix multiplication. And quite often when you get onto a course in artificial intelligence, it will go, you know, have you done matrix multiplication? You actually don't see this if you're using something like the Jetson Nano. But this is what it's doing. It's looking for certain features, and it will take a picture and try and convert it into things that the computer will understand. It'll be things like lines and rows and edges and colors. So it won't look at a thing like we'll look at it. It won't look at a picture like we'll look at a picture. But it will look at it and go, okay, we're looking for certain features. And then the magic of the artificial intelligence, it will go, okay, so if I give you a set of models and a set of pictures that are labeled, what it will do is produce a model that says, okay, you know, so we're looking for this particular thing, we're looking for colors more, or we're looking for edges more, and we're looking for rows more. And it produces this thing called a model that says, okay, if you feed me these inputs, I will classify it as one of these 4 or 5 inputs, 4 or 5 outputs. And one of the things we can do on this is do a thing called, so Andrew mentioned this last month as well, transfer learning. So we take an existing machine learning model, which someone more clever than me has done, and then just tack a bit of code on the end that goes, okay, if I give you a set of pictures with these 5 labels on them, you can take that and process that as, it'll take that and it'll give you an output. So I'm going to switch screens, and I'm now going into this thing. Now, this is my machine learning model, but I don't think it's working. So let's just try try loading this again and see if we can get it going. So I'll talk through it while I'm going, and hopefully we can get something to work. So what this is, it's got a basic bit of Python code. I've got a load of MIDI coming into it as well. But what it's doing is just pulling through. In the side here, we've got a bunch of pictures here that I've labeled. So there's several pictures of me looking stupid. But what I've tried to do with this is to go, okay, if I feed you these things, so that's the chord A5. This is the chord B5. So facing the other way, a slightly different expression. And what it will do is it will go through and it will set up down at the bottom, down here. Now we'll see if we can get this working. Oh, no, it's frozen. I'll try and load this in the background. But what this will do in the background is it will come out with a prediction and it will say, okay, your facial expression at the moment is either A5, or it's most like A5 or E5 or B5, or I've got a stop or I've got a none. And it'll look at these things and it will say, okay, there's a 60% chance that you're doing E5 or 80% chance that you're doing A5. And then what we can do is use that to output to MIDI. Now, if it's going to work, let's see if it's going to work. You know, we're a bit of a challenge with the MIDI side of this. I'll keep this running in the background, and in the meantime, I'll talk through sort of the rest of the slides once that's learned. Hopefully we can kick it off at the end. So it's kind of a stupid idea. So what I was hoping it was going to do was, you know, I would make faces in here. The synthesizer would play chords in the background. I would play the solo from I Want to Break Free, and it was going to be doing the keyboards, and I was going to be doing some bad guitar playing. But it looks like it's not going to work quite like that, so I'm really sorry about that, everyone. So this was the idea that, you know, I could make faces, control the synthesizer while I played guitars. That gets rid of your problem with a keyboard player, and it also gets rid of, well, it doesn't really get rid of the guitar face, but you can use the guitar face for something useful and not just looking daft. So that's a silly project, but in fact, there's quite serious applications for this. So this guy here is a guy called Jason Becker, who was in an early 80s band called Cacophony with a guy called Marty Friedman, who went on to be in lots of big guitar bands and stuff. And at one time, Jason was part of the David Lee Roth band, who was in Van Halen. So, you know, he was quite a big internationally known guitar player. His career ended up being cut short by ALS. So he was contracted with that thing in the early 90s. And by 1996, he lost the power of speech and he lost the ability to use his hands. He's still alive today. He can communicate using a system that his dad developed, which, you know, there's a lot of parallels there with Brian May and Brian May's dad building his guitar. And he uses his eyes to control, you know, to communicate. So, you know, he moved his eyes about, and that'll be certain communications, and he can use it like a keyboard, I think. And also, amazingly, he's still releasing music. So someone's built him a music composition software based on eye and head movement, which was kind of like the silly idea I was going to present if it would have worked. And while I was doing my Google research to get his backstory, amazingly, in 1999, he released a collection of unreleased demos called Raspberry Jams. That was quite a, you know, tying it all together. Now, if you give me just a second, I think we've got the synthesizer working here. Now. So that's not working brilliantly, but you get the idea.
I think we found our theme music for our jams for the future.
Sorry, Alan, what did you say there, sorry?
It sounds like you're creating some music we can use as our theme for our jams in the future. Some, to get people in the mood, because it's all a little, Michael has said in the chat, gloriously silly. He really loves the idea.
So it was working fantastically well up until I had a job interview on Friday and I had to trim my beard and my moustache. So this is one of the challenges with doing this kind of thing. Oh, you've got to, like, if you're doing a proper, artificial intelligence model, you should have hundreds and hundreds of pictures. I'm working with about 100 here, stuff like that. So I had to go and retrain the model, and it's kind of working a bit patchy at the moment. But you get the idea. That was sort of controlled with my face, turning around. So I think one of the things I was going to say is, what did I learn on this project? What was I trying to learn? How to train a neural network, how to use AI for fun. I was trying to learn the guitar solo for I Want to Break Free. What did I end up learning on top of that? How to rebuild a Linux kernel, because for some reason the Jetson Nano doesn't come with MIDI support, which was a total, if I had hair, I'd have been pulling my hair out last week. What overfitting means, what all the matrix mathematics actually does in artificial intelligence, and also some chords, because I'm useless on music theory.
That's brilliant, Scott. I did have something I wanted to ask you. I'm just going to remind with some of our other presenters, we've got coming up next, we have Paul, and then we have Mike before we have Garry. So Scott, one thing, I think I've asked you this before, which is since lockdown last year, we've run about 11, 12, I don't know, I've lost count of these. And of all of those, I think with the exception of one, you've presented every month. And I wonder, do you feel maybe a little bit like Geraldine might say the same? When you say, right, I'm going to come next month and I'm going to present, do you think that kind of helps focus you towards getting your project finished? Is it something that's welcome that you would encourage other people to do? I mean, like you said, oh, well, it worked earlier and it was in the demo, and you've said to me a few times, oh, I'm trying to work on something to get it ready. Do you think it's giving you a good focus as such?
Yeah, it definitely does, because I'm one of these people that, I've probably got about 100 ideas that are sort of percolating in there. But then, as I was saying, as soon as you said guitar stuff, I was like, I know what I'm doing. I've had this one in the back burner for ages. And then it's taken me on a total. So Andrew Robinson, I can't remember what the French term he used for it when he was talking about his machine learning thing. But originally, this project has taken lots of twists and turns on the way to getting here today. And at one point I was going to be wearing cardboard masks with Brian Lee on it and stuff and flipping them off because I thought that was going to work better. But yeah, it's, I love presenting these things, and I love having something to aim for, and something, in a month I've got to go, I've got to get that thing together, and it just helps you distill down those things. And you're all such a friendly bunch as well and put up with the nonsense. So
and there's a good reason why I ask, is because you've come back month after month after month, and you're very happy to share projects that you've been working on. And I mean, I think it would be fair to say not all of them have been completely finished, but it's so nice to see these, because that might just be the spark that makes somebody else think, oh, maybe I could go away and do something like that. So yeah, thank you.
And that's kind of what I like about presenting these things. It's like, as you say, I mean, this one's been the worst one for not working properly, but maybe someone else is looking at this and will go, oh, wait a minute, but he's doing that on a 60 quid computer. I'm going to go away and investigate that. Or that doesn't actually look that hard. Or that guy's clearly an idiot and he's managed to get artificial intelligence working. So maybe I can too. Do you know what I mean? And that's how I've started doing stuff. I started doing stuff because some of my friends built this thing that's now in the National Museum of Scotland. I went, that's absolutely it. I'm like, it took, it paid attention to its Twitter feed and how positive the Twitter feed was. It played jolly music and it was like a cupboard with lots of instruments in it. And it was amazing, but I was like, but I know those guys. Do you know what I mean? They're not Einstein. So that was what encouraged me to get stuff. And do you know what I mean? I think that's a good thing about the Raspberry Jam, is sparking ideas in people and going, maybe I could do something like that.
And there was another aspect as well of your project I thought was particularly funny, which is some people, when they're playing an instrument, whatever that may be, they have like their concentrating face, so they're playing music and you know, sometimes it looks quite painful because you know, their emotion on their face, it's contorted in different ways as they're trying to find that particular note. And you could say, oh no, it's all part of the performance. You know, that's how I play my instrument.
Yeah, see, well, I'm quite, like, the young family are quite bad for concentrating face. Like, it's a well-known failing that we have. Like, if we're stuck in something, it's like, you know, we've all got this bad face. My daughter does it too, so
Absolutely.
it's a family trait.
So Scott, you'll be joining us in our after show party.
Sure will.
As usual. Thank you very much for joining us again.
Thank you.
We're very lucky to have different presenters tonight. And next up, we have Paul, better known as Dr. Footleg to the world. And Paul has spent months preparing his presentation for this evening, as he doesn't mind me sharing that with everybody else. And he's just clicking on a few things he's just opening a new presentation now, and he's going to start creating his title slide. Stick a few images in. Okay, Paul, you ready?
Talk's written. Can you see the screen share?
I can, yeah. I can see a photograph of a very fancy wrist gadget.
So I talked at a jam a few months back about my LED animation library, which was kind of ran on different matrices, different devices. And this was an Arduino watch that you can program the entire user interface of. And it is just a source of LEDs. But these aren't the only LEDs that I was playing with. And you can see in the background that, just give the video a couple of seconds to get there. There's other types of LED matrices. So on the left here, there's a unicorn hat from Pimeroni, and that's a 16 by 16 LED matrix. And on the right is one of these LED matrix displays that you may have come across. They're lower cost, but they're quite a different beast. And I just get that video back to. So the LEDs in the unicorn hat and the sort of LEDs that, well, the LEDs on the watch were an OLED display. So you tell the display what kind of image to display, and it does the magic. The kind of larger matrices have got individual LEDs. So this one has got LEDs. They're a little bit like the kind of near pixel strip LEDs in that you tell the LED what color you want it to display, and it will hold that color. When you've got a long strip of near pixels, you send the data stream to the LEDs, and each LED has its own controller, and the controller determines what that LED does. So once you've told it to display in a particular color and brightness, it will hold that configuration until you tell it a different configuration. The matrix that you see on the right is a different beast, and it's got a lot more LEDs. In this case, there's 32 by 32. And here I'm running it off a hat that was from Adafruit. Just play that again, it's quite a short clip. So it shows that these are kind of full RGB LEDs. And they come in different sizes. So the one we were looking at is the one on the right here. It's a 32 by 32. But you can also get 64 by 64 LED versions. Now that's a lot of LEDs to program. And the way that these displays work is they don't actually put all the LEDs on at the same time. What they do is you address a row of LEDs at a time. So the hardware, when you tell the display that you want it to display a kind of a graphical layout of 64 by 64 pixels, it actually flashes one row at a time with the particular bit of data. But as soon as it stops telling those LEDs what data to show, they turn off. So the way that it appears to display continuous color is it does it very quickly. And that is the root of how you manage to program so many LEDs, but it also is the root of some of the challenges which you run into. You can drive them with various hardware. So as I said, there's an Adafruit hat, which this is the same hat I was using before, but before I'd soldered all of the headers onto it. And this also deals with one of the other challenges, which is power. So these LED panels can draw quite a lot of power because there's a lot of LEDs on there. And so the Adafruit hat has some 5-volt power management, so you can plug in a more powerful power supply. It provides polarity protection so that you're less likely to emit magic smoke from your electronics, and it interfaces the control, the pins on the Raspberry Pi to the connector, and it also has a real-time clock, so you can use this to kind of build a kind of clock display, and it doesn't forget the time when you reboot the Raspberry Pi. So running the Adafruit hat, I was able to get my LED animation library, and this looks like all of these LEDs are on at once. But remember, in reality, what it's doing is it's flashing one row at a time as it goes up the display. And it just does it so quickly that to the human eye, because of persistence and vision, you don't see any of them appearing to be kind of on and off. This method of addressing one row at a time means that you can actually chain these panels together. So here now I'm running 2 panels. So each panel's got 4,096 red, green, blue LEDs on it. So we're already in excess of 8,000 LEDs on these 2 panels. You can actually see there was a 3rd panel there. So once I started playing with these, things started to get a bit out of hand, because I thought, well, if I'm going to order them from China and have to wait weeks and weeks for them to arrive, then I might as well order a batch of them. So I ordered a set of 6, and you can see they come all these ribbon cables. The ribbon cables link, they have an input and an output port. So you just chain them together. So here you can see 4 of them running that same animation, and they act like one continuous panel. And these are sold actually for the purpose of building these huge television display screens. So if you go to Times Square in New York or Piccadilly Circus in London, then the massive advertising hoardings, you see at a rock concert sometimes, giant TV screens so that the audience who aren't kind of in the first sort of 100 or 200 rows at Glastonbury can still see the artist on the main stage on a massive screen. They're made up of lots of these LED panels. And as I said, things started to get a bit out of hand. I got 6 of them running, and this started to pose some challenges because, as I said, you've got a lot of LEDs on here, and if you put all of them on bright white at full brightness, then the panel can draw somewhere in the region of 4 amps of power. So when you get 6 panels, you're looking at a lot of current. So I started wondering, well, how am I actually going to provide enough power to run all of these? I need a kind of higher current power supply. And so I started designing power regulator circuits. You can see the PCB design on the monitor in the background. This is my game of life animation. Now this is the saving grace, is that a lot of things that you kind of want to display on these panels don't actually have all the LEDs on at once. And so the current requirements when you're displaying a typical this kind of displayed image is maybe kind of 3 or 4 amps, which is a lot more manageable. But you need to be careful, because if you sent code to turn a lot of the LEDs on at once, then the current draw will leap, and if you haven't got a power supply that can deal with that, then something's going to overheat or go up in smoke. So I designed this power regulator board that could actually supply me with 5 amps at 5 volts, and by being careful with the code, I was able to limit the current. So here you can see it's drawing just about 2.5 amps. And I've got 4 panels running here with about half the LEDs on at once. You can also, in this video clip, start to see the challenge of the LEDs not all being on at once. And this shows up a lot more in video than it does in, so to the human eye, you don't see this scanning, but because the video is taking sort of 30 frames a second, and those frames aren't quite in sync with the speed that the panels are flashing the LEDs on and off, you see this kind of banding quite often when you take videos of the displays. And just to show that they are all one continuous display, here's my kind of pixel sand animation running across 6 displays. And you can see that I've kept the number of pixels that are on in total to about a third, or maybe even a quarter here, so that I don't overload my single power supply board. But now I've designed this board, I can actually run kind of multiple of these boards so that I can provide power to pairs of panels, and therefore be able to supply a lot more current. Now, the Raspberry Pi Pico came out this year, and this is another microcontroller board which is ideally suited to this type of complex data kind of control problem. And you can actually run these panels. Here's my very sophisticated Raspberry Pi Pico to Hub 7.5 adapter. Hub 7.5 is the connector that these panels use with this ribbon cable. And you can see I've gone for zero sophisticated electronics here, and I've just connected pin to pin with some ribbon cable. Technically, the displays run off 5-volt logic, but actually all of the ones I've found so far are quite happy to take 3.3 volt logic, which is what the Pico has. So I didn't need to use any level shifters, and just with a bit of soldering of a connector to the Pico, I was able to run the Pico example, which you can see here. If you squint, I don't know how big your screen is, but it from a distance you can see it's a photograph of some mountains. If you squint, it helps to kind of make the image kind of blend between being a series of individual dots. But when you photograph these, often they don't actually come out looking quite so beautiful as it does in real life. And this again is down to this scanning. So if your shutter speed is too quick, then you might get strange color artifacts. These are all photographs of the same static image. And you can see that sometimes you get banding where there's a group of them which aren't on for the full cycle of the frame that you took. So I decided to put my Twitter avatar photo on because I wanted to work out how to encode my own photos. And I was having so much fun with these panels, and I had one that actually had a damaged corner where there was an LED missing. So I thought I'll buy a couple more from the same supplier, same specification. So I've got some spares in case I break one. And when I attached these new panels to the Pico, the colors came out looking really quite awful. That's the same photo, same code, same Pico, the same panel technically from the supplier, but actually when you look at the PCBs, the panels had completely different layout of all the chips. So although they're the same data protocol, there's clearly something different about this panel, and the Pico code does not give the right colors. And I've not been able to get to the bottom of what it is about. I don't see this problem with the code library running on the Pi 4 with the Adafruit hat. So it's, I think, a timing issue, because timing is quite critical here, because there's these LED rows are being toggled on and off with a timing signal, and there's red, green and blue timing signals for the components of each LED. And I think what's happening here is that they're slightly out of sync, or it's missing one of the bits off the data stream. And so it's causing this problem with the colors. And you can see it more clearly here. So here's 2 of the original panels and the 2 new panels running the same, they're all attached together, showing the same image on the Pico. And you can see that there's banding which isn't present. These are supposed to be a smooth graduation from kind of purple through the rainbow, from red through to purple. And these kind of sharp color bands are some artifact of this timing problem with the Pico. You also get this problem sometimes when you take a photo that the scanning is again out of sync with this. This I think was taken on a different camera, and it's one where the shutter scans across the CCD. So as the panel scans up, your shutter is scanning across, and so you're effectively taking lots of images of the panel, of slices of the panel over a time interval. And so I've got diagonal lines across here, which is an artifact of the way that camera shutter works and interacts. And here you can see the banding. Now, the banding looks worse here, and that's not just because I got unlucky with my timing, but because the more panels you chain together, and this one's running off the Pico, the less time each LED is on for before it has to move on to do the next one, because it's got to refresh now 4 panels worth, and it's doing a row at a time. So it's scanning up the panels, and now the clock is not able to run so quickly because the processor can't keep up with sending the data. And so the more panels you add to the chain, the more flickery it gets. So this is the second problem I ran into, and I could not actually get a nice image with the Raspberry Pi Pico on 4 panels. It started to look quite visibly flickery even to the naked eye.
If I can interrupt, Paul, this
yeah.
kind of reminds me what it's like when you have so many great presenters all trying to fit into a 90-minute jam. So would you like another 30 seconds or so?
Yeah, let me whisk through because I'm almost at the end.
Okay.
So I managed to, with the Adafruit hat, get a nice photograph across 6 panels, but it actually didn't look very nice to the naked eye. It looks nice in the photograph because I shut the aperture down to take a long exposure, and so the flickering was all averaged out in the photo. But actually, in reality, they were flickering to the point that it was kind of slightly unpleasant. And you can deal with that in 2 ways. One is to use a faster processor, but in this case, the Raspberry Pi 4 is the fastest Raspberry Pi currently available. With the Pico, I could improve things slightly by upping the clock rate, overclocking it, but that was only up to a limit, and with 4 panels, it was starting to kind of flicker. I could get 6 panels on the Adafruit hat, but it wasn't quite what I wanted. And you can see here that there's this kind of noticeable flicker when I take a video rather than a still. So what I wanted to do was run multiple chains of panels in parallel so that I can send data to them simultaneously. So of course, I designed another PCB. This was based on an open source design that actually was published with the software library, but I did a much nicer layout in a Raspberry Pi hat format. And so I soldered this up, and this now enables me to chain panels off multiple connectors and run them in parallel. And here was my first test of it with 2 chains. So now I've got 2 chains. I can actually arrange the panels in a block of 6 because I can make my display have rows as well as columns. Whereas when they're all in one chain, you have to kind of do that rearrangement in software. Whereas now I can just send an image from my Raspberry hat. You can see I'm using 2 of the 3 outputs to run 2 chains. So now with a bit more hardware, I can get a flicker-free image across the full set of 6 panels, which is important because the project that this is building up to is to build a cube with a panel on each side. So there you go.
That is pretty incredible. We've had some comments on Twitter and on YouTube. We won't have time to go through them now, but Paul, you always join us in our Jam Jar session afterwards, don't you?
Yes, I will, yes.
Yeah. And for people who don't know, everybody's invited to join us in that. So anybody who registered for the event, we'll send a link out in a little while. And we have 2 more presentations to fit in, and they're coming up next. And we have Mike Cook, who we're expecting to join us any second now. I think Mike's waiting in just off stage. He's waiting in the curtains about to leap out. I'm just keeping an eye over my shoulder so it doesn't surprise me when he does leap out. And then we're going to have Garry, and they will be our final event presentations of May. And Mike, I'm just filling a bit of time, Mike, so you don't have to surprise me. You can just smoothly move onto the stage. So Mike will be probably here in a few moments. If not, we may go to Garry. While we're figuring out what's going to happen next, let me tell you what's happening a little bit further along. So we have another jam in June. And today in the news, it was being announced about how lockdown plans and things like that are easing. And from the 17th of May and so on, things are being eased. So it's likely that by the time we have our next jam in June, some people may have travel plans. They may be hoping to go away somewhere for a week or two in the summer. And that's why we've chosen the theme of Tech on Tour. So do you take your tech on tour? Do you just pack your phone? Do you have stuff used to charge up your digital devices? Do you have ways of maintaining contact with networks of computer kinds and human kinds? Do you take things to entertain you? I remember I have a friend who takes a Raspberry Pi and a 1 terabyte drive full of movies when he goes away. So no matter where he goes, he can just plug his Raspberry Pi into the hotel TV and he can stream those movies. I'm not seeing Mike, so I think we're going to move to Garry and then hope that Mike then joins us. I do know that Mike had he did say he might be a little bit late. Garry, are you there? Oh, Mike is here. Mike is joining us. I did say, didn't I? I'd expect he would just kind of step in when we didn't expect it. So Mike, sorry, Garry, stand down for a moment. Mike has just joined us. Mike, we're ready for you when you're ready for us. Of computer kinds and human kinds, do you take things to entertain you? And I can hear myself coming back. It's like traveling through a time tunnel, but it's coming out of Garry's computer. So is it? Where is the audio coming from? Hello, Mike, I can see you.
Yeah.
I'm going to pin your video to the main page.
Lost it again.
Now, I will say, to be fair, Mike was a little bit reluctant to come along and join us. Like, oh, Mike, please come, please come, please come. And here he is. We've persuaded him to join us this evening. And for people who are wondering, why is Mike here? Well, Mike has been building an accessible guitar project. And you can follow Mike on Twitter at @WeGrumphy. That's we spelled WEE_Grumphy. Put that in the YouTube chat. Mike, if you want, we could go to Garry and then you could present after Garry. It's up to you.
Yeah. Can you hear me?
We can hear you. We can hear your microphone.
Right. I completely have lost the Zoom meeting on my.
So sometimes what happens is you end up with a little floating panel and it's moved somewhere into your extended display or something.
All right. Can you see me now?
I can see you. Are you planning to share something?
No, just put me front of stage. Sorry about all this.
Listen, if Freddie Mercury had just stepped on the stage now, we'd be waiting for hours, and we're so glad you've made it, Mike.
Yeah, okay. Well, stick me on then, and we'll get going.
You're on.
I'm on. Okay. I can only see a little one of me. But anyway.
But we can see you perfectly fine.
That's no problem. Yeah. That's no problem. Right. I've been at this guitar making business for quite a few years. And Alan sort of mentioned, was this project based on one that was in one of my books? And the answer was not quite. One of the article you're referring to, the guitar you're referring to, is called the Arduino caster. And I was just looking it out, and it's 12 years since I made this. And I'll not play it because it's only. I'll not play it. I'll put some links on for these other guitars I'm showing you playing. But this is the Arduino caster, and you can see down the side there are some letters E, F, G, A, B, C, and these are the chords. And the clever thing about this one is that you press the F, the chord of F, and then if you press the one next to it, you get F minor. And all the way down the guitar, F, G, G minor, A minor, and so on, all the way down. So you only have to remember the one shape to get all the types of chords. You press that and the one next to it, and you get another chord, and so on. And what this guitar does is it actually plucks the strings for you. So you hold down the chords, and it does finger picking patterns. So we can do that, and that was the first one, the Arduino caster that I built. I've done several since then. I've even made. I saw a reference to Lego. Did you see something like this?
We can see it on the screen. Yeah.
Yeah, that's a Lego guitar made from the Lego Boost system, and you've got this little slider here, and you put the slider on the coloured tiles, the yellow, the green, the red and the blue, and that sends out an infrared beam, bounces it off and works out the distance. So that's a different distance sensor, and you change the chords simply by moving that along there, and doing this strums it, and there's the whammy bar. Okay, but what the latest one I've done is this little thing, and this is in the latest Magpie magazine, and it's a MIDI guitar. All these guitars are MIDI, so I've got this MIDI lead, and I put the MIDI into in this case, this is my Yamaha MU10 sound synthesizer box, and it takes MIDI in, and it's quite a nice quality, and they're quite cheap now. They stopped making them, but this equally could be replaced by a MIDI lead into GarageBand or anything else that'll respond to MIDI notes. So the notes themselves are determined by the MIDI module. I've got two buttons on here, and the sliders on the side, on and off, and the other side's play, and it says blank, but if it's not play, it's set up. So I'll just turn the thing on, and there we go. Here's an interesting little thing. You cannot see the display there, or it's very, very faint. But if I rotate this a little bit, ooh, there the OLED display is coming into play, which tells me that there's a bit of cross polarization going on with the lights along there. So we'll just send that along. Okay, so what have I got here? Unlike the previous, the Arduino caster, you only have to touch one of these stars or squares to make a chord, and the finger picking, or the picking of the guitar, is from this square touch sensor, and the square touch sensor will give me a reading in 2 dimensions. There's this way the Y, and then the X. And what I've arranged it for is that in the X direction there are strings. There are areas which act as strings. Let me. Now you might notice something slightly odd about this touch sensor, in that the sound is produced not when you press the touch sensor, when you press the string, but when you release it. And if you think about it, that's the way a guitar works. You don't get the sound until you pluck and release the sound. And that makes an awful amount of difference into how it feels to play this. and it plays like a guitar and not like a piano, a touch sensitive piano or what have you. So that's the big secret. The notes in that direction, the location in that direction controls the volume. So I can, that's quiet. If I stroke it at the top, that's quite loud, and middle volumes. You can go diagonally with a, so that's a loud high frequency note, low frequency note, or you do the other way around. So you can play this guitar in a number of different modes, and the first one it's in here is it says, you probably can't see that, but it says free play, and this just plays. And by pressing these buttons, I can change the chord, and the list of chords is on the display, and the one with the box around it is the one I'm playing. So this is the chord of C, D, F, E, A minor. So you can play a song with this if you know the sequence of chords to play. And this is the one that was on the video, if you've ever seen that. It's the House of the Rising Sun. There is a house in New Orleans. It's called the Rising Sun. You've got to pick the right buttons. And it's been the ruin of many a poor boy. And God, I know I'm one. So you can play songs however badly, but you need to know the sequence of operations. If I go into the configuration mode, I can put some other chord sequences on, and just let's do this one. And this is a different set of chords, but this time it sends the information to the MIDI controller to be a marimba. So there we go. We can have different sounds and different sets of chords to make the remembering the chords a little bit easier. And also it has a magic variable inside that turns it into a left-hand guitar if you're left-handed. And it's just one little line in the code that you've got to change. Okay, but if you can't remember the chords, then it's got a mode whereby you can put right where you can put the chord sequence in, and so consequently we can play a song, and all we've got to do to change the chord is press the star at the end, and so long as the star at the end is pressed, I don't know if you can hear, there's a different sound of guitar. There's about 3 or 4 different guitars in here. This is a softer one. Red and yellow and pink and green, orange and purple and blue. Try again. Red and yellow and pink and green, orange and purple and blue. I can sing a rainbow, sing a go. You could put that.
You need to put your hat on the table in front of you so we can all
You can-
put bitcoins into it for you.
Oh, whole bitcoins. Yeah,
Yeah.
I like them. They're very good. And I've got a couple of ones in there. I've put the House of Rising Sun in, but I've got some. When I put the video out for this, I got a copyright infringement notice. YouTube says, you are using the melody to the House of Rising Sun. Such and such a company claim copyright on this. And I put a copyright dispute in saying, look, it's a traditional song. You can't have copyright on a traditional melody. And within 3 days, they withdrew their copyright objection. So I thought it was one up to me. And anyway, it's not about the House of the Rising Sun in New Orleans. It's about the pub called the Rising Sun at Hazel Grove. If you've ever gone on the A6 out south of Stockport to Hazel Grove, you come to a junction, Macclesfield Road, and there's a pub there called the Rising Sun, and it's been there ever since I can remember. I can remember driving past it in the late 50s as a child with my parents talking about the Munich disaster. So that sort of that sort of dates it. So the words to that is there is a pub in Hazel Grove. It's called the Rising Sun, and I've driven past it lots of times, and I've been inside it none. So mother, tell your children not to do ya. Mother, tell your children not to do what I have done.
That's fantastic. I think I better just make some noise so we don't get the same copyright infringement notice. Well,
they're my words. You see, I'm not infringing the words.
No. And of course, Mike, just reminding you, Mike, you said earlier that you were going to dedicate that song to Geraldine. You were telling me earlier it's her birthday.
Oh yes,
yes. You remember you said that earlier because
I said that. Yes,
that's right.
Very, she has a birthday with my son. It's his birthday today as well. So that's basically it. It's very easy to make, and what I'll do is I'll put some links to videos and where you can find the plans for the Arduino caster and the Lego boost.
It's very deceptive because when you look at it, you think, oh, this is something kind of childlike, but actually, through the MIDI interface, it's incredibly versatile what you can do with it.
It's very well. I'd say I like the sound. I mean, I'm just doing acoustic guitars, but I mean, there's nothing stopping you doing sort of power chords down if that's the sort of music you like. But it's designed as an accessible guitar because I do a lot of work with Drake Music, designing instruments to less able people to use. And this is designed really to go flat on the table and not to have to be held, and to be able to. You can almost play it with one hand because you can.
It's lovely, and I can imagine it would boost the confidence of somebody playing it to think that music is not quite as complicated.
It's also to allow them to join in. I mean, there's nothing like an ensemble music piece, improvised or the real thing to get you into music and to get you to like it.
Mike, thank you so much. It's always a pleasure and privilege when you come along and join in with any of our jams. And for people who don't know, Mike's got you just seem to come up with all these creative ideas all the time. And if I don't know if you subscribe to, if the audience subscribe to Magpie magazine, but you can, Mike is almost every single issue. There's some project in there, and he's sharing some of his creativity and ideas. So you've had a lot of positive comments in the chat on YouTube. People applauding, saying that they like your musical creativity and all of that. Thank you so much for joining us. And
Okay.
and I did spot you managed to coordinate your guitar with your jumper as well. Very smart.
That's right. I noticed this when I was setting the camera up. I thought, I want to see it. But it's the jumper I'm wearing this week, you know. So
that's brilliant.
Okay.
Thank you very much, Mike. We're going to go to our final presentation now of the evening. And Mike, if you are able to join us in our jam jar later, you'll be very welcome. We'll share the link out afterwards. For those people who are already in the Zoom session, you're already there, so don't go away. So, Garry, are you ready to bring something to
I am, yes.
Yep.
I'm ready.
Yeah.
If you want to hand me over, I'll be more than happy to take it away.
Well, you're there. We can see you. We
Super.
can hear you.
Okay. Well, welcome to the latest instalment of my robot project. Regular visitors to the Raspberry Jam will recognize this thing. It's a robot platform that I created a couple of years or so ago now. I've been doing bits and pieces on it every now and again. Had a bit of a break over the last 6 months because I've been working on other projects, but it was time to come back to it. And I thought this month was an ideal opportunity for me to actually do something which I've been planning on doing for a while, because what I wanted to do this robot originally was to make it into an entertainment robot. I wanted something which would be able to actually sing and dance. Well, I haven't got it singing yet, and the dancing is a bit questionable, as you'll find out in a few minutes. But just before I do that, just explain a little bit about it for anybody who's not seen this before. First of all, how does it work? Well, the main part of it, the chassis, the body of it, is made up of plastic Meccano pieces. I cannibalized a couple of Meccano robots to put this together, but I've also customized quite a large proportion of it now with my own 3D prints. So I've designed the parts for what I wanted and then printed those off. So gradually the 3D printed parts are starting to take over, so eventually it'll be entirely 3D printed. The chassis houses a number of motors. These are all servo motors. There are 3 in each of the shoulders. There's a couple in the elbows, one to make it move back and forth, and the other one to give it some twist. And then there are 5 smaller micro servo motors in the forearm to control the fingers. They're a bit more powerful than the regular ones, the SG90s that many of you will be familiar with, because you needed more powerful ones here to get a bit of a grip on them. The whole thing is controlled, well, it can be controlled with any kind of a microcontroller. I've used the Raspberry Pi with this in the past, and I've also used Arduinos on a number of occasions. And for tonight's demonstration, I'm going to be using the Arduino 2560, which is the mega version of the Arduino, basically because I'm lazy, and if I was to use a Raspberry Pi, I'd have to add a hat to it because the Pi can only drive one servo motor at a time. And then when it comes to programming it, since I do most of my programming in Python when I'm working with the Raspberry Pi, it tends to be rather slow when it comes to doing this kind of thing. So if you use the Arduino Mega, it compiles and produces really fast code, and you can get some fairly swift motion out of it. So without further ado, I'm going to do a demonstration for you now. There's going to be some music playing, and you might want to actually turn your volume up so that you can hear it. But if you're wearing headphones, just make sure that you don't deafen yourself because it is quite loud. Okay, let's take this away. Just a little bit. Here we go. Okay, there seems to be some messages coming through on YouTube here to say that people can only see black screen with words Alan O'Donoghue across them. So you may have missed most of that demonstration.
I'm not sure what happened. Should we, somebody's telling me I've done it wrong. You should be spotlighted. Let me do that again. Would you be able to do that again, Gary?
I can, yes. Okay. It is repeatable, fortunately.
Sorry. I don't know what happened then, sorry.
Right. I'm looking at my feed now on YouTube and it's still saying Alan O'Donoghue. So you're still ruling the roost.
There's just a bit of a delay, but you are spotlighted now.
Right, okay. Could you hear the music last time?
We could, yes.
Right, okay. Let me get set things up again.
So, just let's call that the rehearsal.
Yeah, I'm sure it'll all look great in the edit.
Okay, I think it works that time.
Okay, so that was the head-banging humanoid. So tell your friends you saw us here first.
That was fantastic.
Yeah, that one I scripted pretty much in the same way that I did the Robot Robin that you may have seen in our Christmas episode. So the whole thing was basically handwritten, every movement. So I didn't make use of the control frame that I created last year, which I demonstrated in an earlier presentation, but that's something which I could do in the future. And there's lots of other things that I could do with this as well, obviously, to improve it. At the moment, it's got something like 10 subroutines that control the various motions in the arms and the head, and we could obviously add a lot more to that. I could add some form of sound sensing to it as well, so that it could actually pick up the beat of the music and adjust its style and its rhythm with the music. And I can also introduce more degrees of freedom as well. The robot can actually move more than it did today, so it's capable of tilting, for example, from side to side. And I've got a plan eventually so that it can move, tilt backwards and forwards as well. So that'll help to give more fluid movement. But for an entertainment, it's not bad so far. And the other thing, of course, I want to include is the synthetic singing. I could have it miming to someone else actually singing a song, but it is possible to get computer-based singing synthesis software, and I've looked into that, and that's something which I'm hoping to incorporate into future versions of it. But anyway, we'll see how motivated and inspired I am over the next few months or years in this case. Hope you enjoyed it, and thanks for watching.
This is partly come about, or largely, because we had a Brian May themed jam. So I'm wondering, do we need to give you, say, 3 months, 6 months, and come up with another musically themed jam for it to return, with another project?
Well, you could do, yes, or just announce now that you're going to do another Brian May next year, and that'll give me enough time to get something worked out.
that might be too long a lead time. We might go for, I don't know, maybe our audience can be creative, and on the YouTube chat they can make some suggestions. Maybe Wembley, would Brian, would your robot, in fact, does your robot have a name yet?
Well, no, not really. I just call it the robot.
Yeah, because we keep calling it Gary's robot.
Yes, yeah. I wouldn't want to call it Brian because, of course, there already has been a Brian the robot. In fact, that one off the adverts. So we can't call it Brian.
Okay, that is fantastic, and thank you to Garry and all of our other presenters tonight.